Hello everyone. I hope you all are fine. So today we will study one of the most important topic of quadratic equation, that is graphical representation and location of roots. So first of all, what is the equation for a quadratic polynomial? Yes, very good. It's y equals to ax square plus bx plus c. And here a is not equal to 0. Okay. Now, first of all, to understand its graph, we want to nature of this quadratic polynomial. So first of all, what will be the value of y when the value of x is very high or x tends to infinity? Can you tell me? So y is ax square plus bx plus c. Yes. And here, when x is very high, so x square will dominate x. So with respect to this term, we can neglect these two terms. We can neglect. Yes or no? So this term will define what will be the value of this. Now if you see that it's x square, so infinity ka square will be infinity, and if the a is positive, the whole expression will be positive and it will go to infinity. And if the a is negative, the whole expression will be negative and it will be minus infinity. You can see it like this also. If you take common x square, the highest power, what will become? B by x plus c by x square. Yes or no? Now, if x tends to infinity, this term will tend to 0. This term will tend to 0. So, what will come? A into x square. And if a is positive, again the same concept, it will be infinity. And if a is negative, it will be minus infinity. Yes or no? Now, for x tends to minus infinity, that means when the value of x is very small, what will be y? This will be ax square plus bx plus. Again, the same thing is same because it has x square. So either it's infinity or minus infinity, does not matter. It will have the same value and we can neglect these terms with respect to this. So it will come infinity for a greater than 0 and minus infinity for a less than 0. Yes or no? You can see it like this way also. So here the value of a, when it is positive, it will come to infinity, and when the value of a is negative, it will come to minus infinity because it has x square. So x tends to infinity or x tends to minus infinity, it's the same. Yes or no? Okay. So we have understood some points that when a is positive, limit x tends to infinity fx or limit x tends to minus infinity fx. That means when value of x is very high or very small, the value of y is infinity, tends to infinity. Yes or no? So, if you want to plot this thing in the graph, what we can say? That if a is positive, I don't matter what will happen in the middle part, but when the value of x is very high or when the value of x is very small, it will go towards infinity. Yes or no? Have you got this? Yes. So the curve will open upwards. Can you say that? Yes. For a less than 0, doesn't matter what happened in the middle. Again, when value of x is very high or very small, the value of y will go to minus infinity, as you can say, for a less than 0. So it will come to minus infinity. I don't know what will happen in the middle, so but we can say it will open downwards. It's clear? Okay. Now if we talk about the roots of this quadratic polynomial, we can know about the middle portion, that we will touch or cut the x-axis or not. So as we already know that y equals to x square plus bx plus c, any quadratic polynomial can have max to max two roots. So can you tell me the conditions? Yes, when d, that means discriminant, that is b square minus 4ac, that is greater than 0, what will happen? It has two real and unequal root. When d equal to 0, it is 2 real and equal root. And when d less than 0, it has 2 imaginary root. Or you can say no real root. Yes or no? Clear? Okay. So when there is any root of any curve, any function, for example, if y equals to fx, this fx has in one root at x equals to alpha. So fx equals to 0 at x equals to alpha. So that means it will pass through the point alpha comma 0. Or we can say it will either touch or cut the x-axis at alpha comma 0. When it will touch and when it will cut? Can you tell me? Yes, when the root is of even multiplicity, it will touch. You have already studied this concept now. And when the root is of odd multiplicity, it will cut. Yes or no? Yes or no? Okay. Now we'll understand the graph in a very beautiful manner. So first of all, we have now two parameters. One is A and another is D. So first talk about what will happen when A is greater than 0, D is greater than 0. Yes or no? So the A greater than 0 means it is open upwards. But D greater than 0 means? D greater than 0 means? Yes, very good. It has two real unequal root. Yes or no? Very good. Great. So what will be the graph? That means it will have two roots alpha and beta and it will open something upwards. Can you tell me these roots are of even multiplicity or odd multiplicity? Yes, ax square plus bx plus c. If you write in the factor format, that will come a into x minus alpha into x minus beta. So both the roots are of odd multiplicity. So it will cut. It will cut and then again come back to beta. It will again cut. Yes or no? Yes or no? So the graph will look like this. The graph will look like this. But if a greater than 0 and d less than 0, then what will happen? Can you tell me? Then can you tell me? Yes, it will neither cut nor touch because there is no real root now. So the graph will look like this. And if a greater than 0 and d equal to 0, can you tell me? Yes, very good. Now it will touch because both the roots are same. So it will look like a into x minus alpha square because alpha and beta are same now. So it's of even multiplicity. This root is of even multiplicity because the power is 2. So it will touch at this point and go like this. Yes or no? Have you got this? Okay. So can you tell me what will happen in case of a less than 0? Yes, only the graph will be open downwards. So for d greater than 0, again both the roots but only open downwards. This is for d greater than 0. For d equal to 0, yes, both the root will be equal, so it will only touch. And for d less than 0, it will neither cut nor touch. Have you got these points? Or is there any doubt? Is there any doubt? Okay, no doubt. Very good. Now, there are two more important things that I want to mention. That when a is greater than 0 and d is less than 0, see the value of the quadratic polynomial. It is always positive. So in this case, fx is always positive for all x belongs to R. Yes or no? And in this case, when a less than 0 and d less than 0, fx is always negative. Fx is always negative for all x belongs to R. So these are very important points that if a quadratic polynomial is positive for all x belongs to R, that means it has a greater than 0 and d less than 0. And it is if it is always negative for x belongs to R, that means it has a less than 0 and d less than 0. Have you got this point? Now what will happen if we do y equals to ax square plus bx plus c greater than equal to 0? Greater than equal to 0. That means which case will come? Yes, this case will come. It also touching the equal to 0 and also going in the positive side. So this case, that means d equal to 0 case can be incorporated. So that means here d can be either greater than 0. Sorry, d can be either less than 0 or equal to 0. And a is positive. And if we say ax square plus bx plus c less than equal to 0, then which case will come? This case will come also along with this, because here d is touching the 0 point. So what will come? Yes, d less than equal to 0 and a less than 0. Clear? So are all of these four cases are clear? And these are very much famous topic for JEE mains and advanced. So many questions have been asked from this topic. Okay, that's clear, I hope. Yeah. Okay, now I want to know something more important points, like if you understand very carefully here, when a is positive, the curve is open upwards. That means it has some minimum value at some point. I don't know what is the minimum value, but at some point it has some minimum value. And when the curve is open upwards, it has some maximum value. The minimum is minus infinity in this case, and in this case maximum is plus infinity, but in this case it has some minimum value, finite minimum value, and in this case it has some finite maximum value. Now how to find the maxima and minima? Yes, either you can do the differentiation or completing the square method. So let's see what we can do. So if you see y equals to ax square plus bx plus c, and if you complete the square, so if you take a common, that will come x square plus b by ax plus c by a. Yes or no? So what will get? That will get x square plus 2 into b by 2a. We are completing the square. 2 into a into now b is b by 2a. That is b by 2a whole square. And we are adding this term extra. So we have to subtract it also, plus c by a. Yes or no? So what will come? A into, tell me, x plus b by 2a whole square minus b square by 4a square plus c by a. That's clear? Or is there any doubt? Tell me. So what will come? A into x plus b by 2a whole square minus, tell me what will come? This will become 4a square and b square minus 4ac into a will come also. So one a will be cancelled out. What you will get? A into x plus b by 2a whole square minus b square minus 4ac by 4a. Yes or no? Tell me. Okay. So if a is positive, understand this very carefully. If a is positive, this whole value will be positive. This whole value will be positive. So a into x plus b by 2a whole square in this case will be greater than equal to 0. So the full expression we can say is as d na, because d is b square minus 4ac. So the full expression will become greater than equal to minus d by 4. Yes or no? So the value of y, is greater than equal to minus d by 4. That means the minimum value of fx, that is minus d by 4. And it will be achieved at what point? When this thing will be 0. So that means x plus b by 2a equals to 0. That means x equals to minus d by 2a. So in this case, it will have minimum value at the point minus b by 2a comma minus d by 4a. It's clear? Minimum. But when a less than 0, the whole thing will be less than equal to 0 because this is positive, but if it is negative, the whole expression will be negative. So fx will be equals to a into x plus b by 2a whole square minus d by 4a. It will be, this is less than 0, so that will be less than equal to minus d by 4a. So the maximum value of this is minus d by 4a. Yes or no? Yes or no? Yeah. So that means here, and the maximum value will occur at the point x equals to minus b by 2a. So here the max value occurs at the point minus b by 2a comma minus d by 4a. That means when a is positive, this minimum value, this point is minus b by 2a minus d by 4a. Value of x is minus b by 2a, and at this point the value of y, that means the minimum value of fx is minus d by 4a. And for this, when a less than 0, this is your minus b by 2a comma minus d by 4a, but it will occur as maximum now. So in this case, the range will be range of the quadratic equation. If you ask, range of quadratic equation will be minus dy 4a to infinity. In this case, range will be minus infinity to minus dy 4a. Have you got these points? Yes, very good. So that means you can mark these points also now. You can mark these points also now very carefully, very easily, minus v by 2a and minus d by 4a. So here you can say d is d is equal to 0. That's why it is touching the x-axis also. So because d is 0, so minus d by 4a will also be 0. So that's why it is coming 0, the y value. Yes. So you can mark this all of these points, I hope. Okay. So I hope these all things are clear. These all things are clear. Okay. So for two-liner summary, what we have understood till now, that when a is positive, the quadratic will be open upwards, and when a is negative, the quadratic will open downwards. And when d greater than 0, what will happen? This will cut the x-axis into points. When d equal to 0, it will touch, and when d less than 0, it will neither cut or not touch. D greater than 0. And what we have understood something more points, that is here the polynomial fx is always positive, and if we say fx is greater than equal to 0, then we will take this case and this case also both, and for a less than 0, what will happen? This all will be open downwards. So for d greater than 0, it will look like this. For d equal to 0, it will look like this, and for d less than 0, it will neither cut nor touch. So in this case, as you already remembered, that fx is less than 0. Fx is always negative. And if we combine these both the cases, fx will be less than equal to 0. Yes or no? That's clear, I hope. Okay. Now, also we have marked these points. In this case, the range will be minus d by 4a to infinity in all the three cases. Yes or no? This is the point, and this point is also called vertex. So the vertex point is minus b by 2a comma minus d by 4a, and here the maximum value is minus d by 4a and the minimum is minus infinity. So this will be the range, and this is the vertex point. It is minus b by 2a comma minus d by 4a. You can mark this point for all the curves, but I have marked at only one. Okay, that's clear, I hope. Okay, now we'll proceed to location of roots. So first of all, I will consider the case if both the roots both the roots of the quadratic equation are greater than k. That means there is some value k and both the roots alpha and beta, they are greater than the value k. That means k is something here. Or the figure can be like this also. This case is for a less than 0. Yes. So this is your alpha now, this is your beta, and this will be your k. Now, if we want to find the condition that what can we comment about k? So first of all, if you see the value of function at the k point, you will see that the value of function in this case is positive. But in this case, the value of function is negative. So here a is positive and f of k is also positive. But here a is negative and f of k is also negative. So if you want to find a common criteria, what we can say? We can say a into f of k, that is positive. Yes or no? So the criteria is a into f of k is greater than 0. Now it has roots, so we can say that d is greater than equal to 0. And also we know about this vertex now. So what is this vertex? This vertex is minus b by 2a comma minus d by 4. And here this is minus b by 2a comma minus d by 4. So we can very easily say the value of k will be lesser than minus b by 2a. Yes or no? The value of k will be lesser than minus b by 2a. So that will be my third criteria. Yes or no? Tell me. So have you got all the three criteria? Yes. Okay. Now, if we just reverse the case and say both the roots are lesser than k, what do you get? That means k is larger than both the roots. It can be like this also, or we can eventually say this also when a less than 0. Yes or no? Okay. So in this case, if you can see here also a is greater than 0, f of k is greater than 0, and here a is less than 0 and f of k is less than 0. So same with the first case, here also a f of k is greater than 0, and there are two roots, so we can say d greater than equal to 0. And if we talk about the third case, now it will be different. Here the minus b by 2a point is somewhat here, and here for this it is somewhat here. So here the value of k will be greater than minus b by 2a. Yes or no? So have you got all the three concepts? So only this point is different from it. So if k is greater than minus b by 2a, we are getting this case. If k is less than minus b by 2a, we are getting this case. That means both the roots are greater than k. Okay. Now, if we get the middle of the case, that means one root is bigger than k and another smaller. That means we can very simply say that k belongs to alpha comma beta. Okay, that means there is somewhere alpha here, there is somewhere beta here, and k lies in between. It can be look like this, it can be look like this also. So first of all, if I ask, what should we say about k? That we can very easily see that f of k is negative here when a is positive. And here when a is negative, f of k is positive, if you can see. Yes or no? So in this case, a f of k that is coming less than 0. Yes or no? And if we talk about d, it will be greater than 0 or greater than equal to 0. Yes, now it will be greater than 0 because k is in between both the roots. So that means both the roots cannot be equal. So only one case is possible, that is d greater than 0. And we cannot comment on minus b by 2a because minus b by 2a can be either bigger or lesser. We cannot say that. So these two conditions will be sufficient. Yes or no? Yes or no? Tell me. But if you actually say, if you really think that d greater than 0, only in this case f of k can be negative. If you really think that in this case, only f of k is less than 0 is possible when d greater than 0. Yes or no? Here, for a less than 0, f of k greater than 0, this case is only possible when d greater than 0. Because in all the other cases, the curve will look like this or this. So here f of k is always negative, here f of k is negative or max to max it is 0. So it can never be positive. So only in this case it is positive. So if we only consider this case, we need not to solve this case separately. So only solve this case a f of k less than 0 and you will get your answer. Have you got the point? Because the region of this will automatically come inside this. So if you take the intersection, you will only get this case. Yes or no? Now, if you talk about 2 points, that means we are talking about now two numbers which lies outside or inside the roots. So if you talk, first of all, that there are two roots alpha and beta, and there are two numbers k1 and k2, let's assume. One is smaller than both the roots and another is larger than both the roots. So you have already understood the conditions now. So what we can say here? Yes, a f of k1 that will be greater than 0 because we have already studied that if a point is smaller than both the roots, we have got this condition. We can also draw this kind of graph also. Here also we'll get the same thing. That here f of k1 is negative, but a is also negative, so f of k1 will be positive. And for a f of k2, what we can say? Yes, it is greater than both the roots. So in this case also it will be greater than 0. Acha, can you comment about D? Yes, D will be greater than or equal to 0. Acha, can you comment on minus b by 2a? Yes, minus b by 2a is somewhere here. So we can say that k1 will be lesser than minus b by 2a and lesser than k2. That's clear? Yeah. Okay, all right. Now, if you just put one point inside and one point outside. So what will happen? That means one root is inside. Let's assume this is k1 and this is k2. Or we can think about this also. Here for a greater than 0, we can eventually draw two cases. Wait, one time is k1 is outside, k2 is inside. This can also be possible. Okay. And for a less than 0, again we can draw two cases. This is my k1 and this is my k2. This is my k1 and this is my k2. Yes or no? So here we cannot really comment about f of k1 because in this case when a is positive, f of k1 is also positive. But here when a is positive, f of k1 is positive. So here if you see a positive, here a negative. But here f of k1 if you see it is less than 0. Here f of k1 it is greater than 0. But in this case f of k2 which is tell me less than 0, in this case f of k2 greater than 0. So the sign of f of k2 or f of k1 keeps changing eventually when a is same. So that means we cannot really comment on f of k1 or f of k2 separately. Rather than we can say that when f of k1 is negative, f of k2 comes positive. When f of k1 comes positive, f of k2 comes negative. And same with these cases also. So generalize, if we can state this thing, f of k1 into f of k2, that will be less than 0. Yes or no? That the sign of f of k1 and f of k2 is always opposite. Yes or no? Okay. Now what we can comment about d? Yes, d is greater than 0 because equal to cannot come because k1 lies inside. Okay. And we cannot really comment about minus b by 2a in this case. Okay. So, but tell me, d greater than 0, is it necessary? Yes, it is not necessary to calculate. If we calculate this case only, we'll get the answer. Because only for d greater than 0, these kind of cases are possible, not for any other cases. So, this is the intersection case of this. This is a subset of this. Now, if we talk about both the roots lies inside that means the graph will look like this. Yes or no? Tell me. Yeah. So in this case, if you see, when a is positive, f of k1 is negative and f of k2 is also negative. So a positive, but f of k1 and f of k2 both are less than 0. And here, when a is negative, f of k1 is greater than 0, f of k2 is greater than 0. That means we can say a f of k1 is less than 0 and a f of k2 that is also less than 0. Yes or no? We need not to separate in this case. Yes. And can you talk about d? Yes. D will be obviously greater than 0. Clear? Clear or not? Tell me. Yes. Yes. That's clear. That's clear. Okay. These all the cases are clear. Now let's solve one question regarding to this. I'm just taking one question only. So find the value of a which for which the quadratic polynomial, let's take 4x square minus 2x plus a equal to 0, has two roots lie between -1 and 1. Okay, -1 and 1. Clear? That's your question. So tell me, which case is this? That both the roots are between this. That means one root is smaller and one root is larger. Yes. That means what we can say here, a is positive. So a f of -1 that will be positive and a f of 1 that will be also positive. And we can very easily see a is positive. That means f of -1 will be positive and f of 1 will also be positive. So if you solve f of -1, what will come? 4 into -1 square minus 2 into -1 plus a, that will be positive. That means 4 plus 2 plus a, that will be positive. 6 plus a. And in this case, it will come 4 minus 2 plus a, that will be positive. So that means 2 plus a is positive. Yes or no? So here we are getting a is greater than -6. Here we are getting a is greater than -2. Yes or no? And if we do d is greater than equal to 0, that means -2 whole square b square minus 4ac, that means 4 into a into 4, that is greater than equal to 0. That means 4 minus 16a, that is greater than equal to 0. That means what we are getting, that a less than equal to 1 by 4. Okay, and any more case that we need to solve? Have you solved all the cases? Do you need to solve minus b by 2a? Okay, let's solve. What will be minus b by 2a? Tell me. The minus b by 2a value is, minus b by 2a value is, tell me. Minus b is your 2 and 2a will be 8. Yes or no? Minus b by 2a, let me write. That will be, b is your minus 2 and a is 4. Don't be confused. So this will be 1 by 4. So a should be that 1 and minus 1, that should be between 1 by 4, and there is no, this is obvious thing, yes or no? That minus 1 and 1, in between these 1 by 4 comes. This is so much obvious, there is no issue. So a will be, in one case a will be less than 1 by 4, less than equal to 1 by 4. In another case a is greater than minus 2, minus 2 will come somewhere this, and in another case a is greater than minus 6. It will be look like this. So the intersection of all the cases, that will come minus 2 to 1 by 4, and that will be the answer for this question. That if a becomes minus 2 to 1 by 4, then the value, then the quadratic polynomial will have two roots between minus 1 and 1. So I hope you all have understood this concept of location of roots. So practice some questions from it, and if you have any doubt, please let me know. Thank you all for joining the session. Have a good day. Bye bye.